Hi guys, today's video is 1.5b and we're going to find approximate angle values, and this is a continuation off of our last lesson. So before we move forward into new material, let's take a moment and just review this last problem from our notes. It was a you try, so you might not have done it, but let's take a look and just confirm that we know what we're doing. So first things, instructions. In A, you're going to draw and label a picture of cosecant theta. In B, you're going to find the value of the function from that picture. So we're going to look for cotangent of theta. In C, you're going to use an inverse function to find theta. And then use theta to find cotangent of theta. Okay. So basically this box should match this if you remember from our previous lesson. Let's take a look and begin. Ready? So in our first box, we know cosecant theta is 1 over sine, and sine is y's. So I know this is y over r. So that's my y. My y is 5, my r is 7, and I can use the Pythagorean theorem, right? So let's see. X squared plus 5 squared equals to 7 squared. Sorry about that. That'll be x squared equals to 49 minus 25. X squared equals to 24. That means x equals to 2 root 6, okay, because the square root of 24 is 2 root 6. So then we're going to go to cotangent. That's x over y, right? So we have our x, which is 2 root 6, over y, which is 5. And let's get a decimal approximation just so that we know what our goal is. Eventually I'm going to round to the nearest hundredth. So I'm going to do 2 root 6 divided by 5, and it'll be approximately 0.98. Okay, that's our goal, and we're going to see if it matches here. So now let's take cosecant theta equals to 7 over 5, and we're going to use inverse functions to solve for theta. But we can't type cosecant inverse on our calculator, so we're going to need to do, this is sine inverse of 5 over 7, right? The reciprocal of what we're looking for. So I'll type that in, inverse sine of 5 over 7. That gives me theta equals to 45.58 degrees. And from there, I can find cotangent theta. So I would type this into the calculator as 1 over tangent, and I'm going to use a and s because that's going to take my answer exactly. So go 1 over tangent of second minus, and that equals to 0.98, which matches right here. Okay? So the previous lesson was not like, there was no purpose to doing it this way, and then this way, right? The purpose of having these 3 steps is so that you can verify that you're heading in the right direction. We're going to do things a little differently now. We're not verifying anymore. We're going to be finding theta of a given quadrant once I give you a trig value, okay? So there's a few things I want you to be careful of. There are 3 things that you really need to do. The directions say to draw a diagram for every step of these problems. So you are going to show the principal value in your diagram, the reference angle, and your final answer. Now, so let's take a moment. Find the principal value using your calculator. Okay, so the first step is solving for theta, because it says find theta, right? And when we do that, excuse me, the number that you get, that's your principal value. Negative 0.7321. I'll type that into my calculator. That'll give me 137.06. Let's assume we're rounding to the nearest hundredths for this entire worksheet, okay? So I have theta equals to 137.06. Since it's theta, it's degrees. And I'm going to take a moment and I'm going to sketch this. This is my principal value. 137 is about halfway. And I'll label this as PV 137.06. Next thing says to find the theta reference angle. So reference angles, remember, are from the angle, the terminal side, to the x-axis. So this is your reference angle. In order to find the reference angle, you're going to take either 180 or 360, right? Whichever one is closest, because we're only doing x's. And then we know that the number needs to be smaller than 180. So I'm going to subtract my answer, which gives me, notice I didn't clear it, 180 minus answer. Now, if you did happen to hit clear, it still would work, or you can go second, enter, and go back until you get that, and then I can go second, enter to get that. So 42.94, that's my reference angle. So let me label that. Actually, let's not. It's going to get a little messy if I label it. Okay, I did label as reference angle. Here's my principal value. And then the last thing we need to do is figure out what quadrant this is in. That's from 180 to 270. So that's quadrant 3. But it's not in quadrant 3 right now. And the reason that is because your calculator can't tell if cosine is a negative value. Cosine is x, right? So if x is negative, it could be positive here, positive y, or negative y, but there's no way to tell just from your cosine. The only way to tell is if someone tells you. So in this case, we want quadrant 3. Now, the problem is that right now we're in quadrant 2, but we're going to use the reference angles. If the reference angle is in the wrong quadrant, we're going to move it using the reference angle to the correct quadrant. So we're going to reflect it. And so now, I'm going to draw the same reference angle, not exactly the same, but it's supposed to be the same. And this is 42.94 as well. And our final like theta is how big of an angle is it from here, 0, to this spot. Okay, so I'm going to draw one big loop here. That's my actual theta. And so I need to figure out what that is. So theta equals to, closest one, right? But it's bigger by 42.92. So I have 180 plus 42.94, which is 222.94 degrees. So I'll label that here. Okay. So please make sure that your graph has 3 values labeled, 1, 2, 3, okay? And then make sure that you have your answers here as well. So let's do it again. Same thing, same steps. I'm going to find theta by using inverse of cotangent. Cotangent inverse of negative 6.478. This is going to be quadrant 4. Cotangent, I can't put that on my calculator, so it'll be tangent inverse of the reciprocal. And then we get principal value of our calculator is tangent inverse of 1 divided by negative 6.478. Oops, sorry, not 0 divided by, but 1. Okay, so equals to negative 8.78 degrees. So let's sketch it. It's going to be a tiny one, and that happens to actually be in angle 4. So my PV equals to negative 8.78 degrees. That's also my reference angle, but we know that reference angles are always positive, right? So reference angle is equal to positive 8.78 degrees. And we can't use a negative value for our final theta because it literally says here the number has to be between 270 and 360. So I'm going to go around and find a coterminal angle. Right? So theta equals, and how do I figure out what that is? Well, I'm going to take negative, if I go in the negative direction, 8.78, then in the positive direction, I'm doing 360 minus the reference angle, right? You see how like we're taking away that small piece? So it'll be 360 degrees minus 8.78 for your answer. Please always use answer on the calculator. Ooh, that's a negative. Let's see. I'm going to clear it times negative 1. Okay, there's my positive. So 360 minus answer. That'll give me 351.22 degrees. You guys good? And here are my other two. But this is my final answer. Okay. I'll do one more, and then you guys are going to try 3 problems on the bottom to make sure that you've got it. Okay, so I'm going to keep saying this. It's very easy to watch a video and just like tell me or tell yourself that you get it, but you really do have to practice and make sure that it makes sense, right? So for these classwork problems, please check with your classmates, especially if you are watching this for another teacher's notes. Please check with your classmates if you got the answers right. Okay, so let's do this one. Same idea, cosecant inverse. See if you can do this one yourself, right? So I think what I'll do is I'll keep working, but you can pause the video here and then forward it to check your answers if you want. And so what you want to do right now is use your calculator to check every single one of my steps, see if I'm making a mistake or if you're making a mistake, because every tiny little thing matters and it will ensure that you know what you're doing. Okay, so hopefully you got 21.80, which is your principal value and theta, your reference angle. We want to be in quadrant 2. So I need to be in quadrant 2 here. And so I'm going to move it same. This is still 2180 reference angle. And so my final theta equals to, we're close to 180, so I'm going to go 180 minus reference angle. Okay, hopefully that was nice and clear. You should definitely practice and check your answers with each other, and then you may start your homework.